Okay, I think we can start. Let's see if more folks join in a minute or not. Yeah, welcome everybody. My name is Christian. I work on Lakekeeper currently. Lakekeeper is an Iceberg REST catalog written in Rust. We will focus a little bit on security, which I'm also going to talk about today, and ease of use, so make sure to check us out. Yeah, so today I want to talk a little bit about how we can secure Iceberg tables. So how can we secure them across also different query engines, which is a surprisingly hard thing to do. So the rough agenda is that, well, I start with the goal, describing a little bit what we actually want to achieve. Then we discuss a little bit where we should store permissions, how we can enforce them with the means that we have today. I also have a very short section, which I call Who Am I, on authentication, because permissions go hand in hand with identity. One doesn't work without the other. If we want to share permissions, we also need to share identities. There's no other way. I also have a little demo showing well, what I'm talking about today, and a small conclusion at the end. Okay, so let's get going. What do we want to, or what are we trying to achieve? Well, like what the naive business user would like to have typically is something like this, right? I need access controls for my tables, but that's actually like hard to achieve because that comes with a lot of like stars and asterisks attached to it, because what they typically mean by that is, well, they want direct access to Iceberg tables, right? They don't want a slow SQL warehouse in between to which we need to connect via JDBC for larger data sets. Also, we might want to use different tools and engines to access data, and not just log into a single tool. Why is that? Well, Iceberg's all about interoperability, so we should be free to choose the engine that we like. We also don't want to deduplicate permissions, right? We want to use those different engines, but we want to have the same permissions no matter what engine we use. We want maybe to grant things on namespace or table level. So in Iceberg, we have this hierarchy, right? We have different namespaces, they might be nested, and we want to leverage that to grant permissions on that. Then also we want to integrate with a company IDP, right? I'm a user, I have two-factor authentication. I'm really bad at remembering a password, so I don't want to, so let's find a different solution. And then there's also the question of row and column level security and how we can enforce that, which is an even harder thing to do. And we'll talk later a little bit about how we can do that using trusted compute engines. So in the end, what we're trying to achieve is something like this here on the right. So we have two different users, like that's me, using two different engines to access a table, right? And I've put logos in many places of like the presentation to make it a little bit more, practical, I guess, but you should be able to swap them out for anything else. And then I have like my weird colleague from the other department who of course shouldn't be able to access the same the tables, right? No matter what tool they use. So this is what we're trying to achieve. And well, I guess the first question is like, why is this problem so hard? And well, the answer is, we had, going back 20 years, we had this amazing thing that we called a relational database system, and that did almost everything that we wanted, right? We had all of these different things here on the right as part of our monolithic service. We had permission management, identity, users, we had a catalog listing tables, physical storage, like that was all built into this one big thing. And then we took Thor's hammer and smashed it into pieces because what we wanted to achieve is a little bit more modularity. And the modularity that we wanted to achieve is that we want to switch out our compute engine, so we want to use specialized compute engines on shared data. And it's not just shared data, right? It's shared permissions, it's shared identities, because all of these things below this little line here need to be shared in this kind of environment. So in order for all these things to be shared, we need open standards for all of them. Because if we want to collaborate with different engines on these things, we need open standards for all of them. So we started to develop them, right? We have agreed on a few different physical storages, S3, Azure Data Lake Store, object stores. We needed a data format such as Parquet, there are others as well. And so we went up the stack and we have the table format, of course, Iceberg, the REST specification now for the catalog. And we agreed on all of these different things. But we haven't really agreed on these last two layers yet. So there is still a little bit of work to do. And my talk today is going to address these two different layers and what we can do about that. So let's first evaluate like this permissions layer here and where permissions should be stored. Like if they are shared, where do we want to store them? And I guess there are a few different options, right? So we could either we can store them in physical storage as we've done for a long time, just have S3, well, permissions basically. We can store them in the catalog or close to it in a dedicated permission management system. Or we can also use the compute for it. So let's go through them one by one. So the first option here is, well, of course, we could go ahead and just store permissions in the physical storage layer, right? So we have our object store and we have our permissions, this orange lock here down there. By doing this, like this is very simple to do, right? And it also works across engines. Like it's not too bad, one might think at first, but then there are a lot of problems that come with it. So first of all, we always have limited granularity, and the reason for that is that we have no semantic understanding in the storage. Like a typical object store doesn't understand Iceberg, right? So if we wanted actually to secure our data at the storage level, we would need something like S3 tables that has a semantic understanding of Iceberg and can actually secure it properly. But like a regular object store can't do that. Also, in Iceberg, we have the separation of data and metadata. So we would need to duplicate permissions from the storage to the catalog. So like all in all, like this is not a very good solution. There's a reason why we have, you know, lake formation on top of S3 and all of these kinds of things. We don't want to secure our storage. And as the saying goes, we should secure our data and not the storage underneath it. So next up, the compute. And I guess like this is also something that we've done for a long time. We just, you know, have permissions inside our query engine. And that's, of course, great because we have arbitrary granularity. We can secure expressions, row and column level security, of course, and everything else that our engine is capable of. Like, it's the best possible experience inside one engine. And that's, well, kind of beside the goal of this talk because we want to talk about sharing permissions across different engines. So if you have permissions in one engine, it's really hard to share it with another without actually going through this first engine. So yeah, as I said before, Iceberg is all about interoperability, so we shouldn't store permissions in engines because then it's less interoperable. Also, of course, models between different engines can be very different by itself. So what's next? So the next layer that we can look at is the catalog. And this now is the first like place where we say, well, now if we have our permissions in the catalog, then at least it's at a central place, right? So we have a single place for shared permissions, and the catalog, being an Iceberg catalog, also has some semantic understanding of the hierarchy and everything. So it's consistent across engines. Currently, we don't have a standard, though, for how to actually store permissions in a catalog, and I think this is one of the major things that is currently missing, and I'm going to talk later a little bit about how we might be able to work around that. One core thing to note here is that if we store permissions somewhere and one system and access it with another system, this can only work if we also share identities between all of these different systems, right? Because if a compute engine with its local user tries to connect somewhere, if we don't share the same identities, we can't share permissions. It's simple as that. So yeah, so this seems already like a reasonably good solution. We can also go one level further, which is having a dedicated permission system in which we store our permissions, to which both the catalog and different query engines can connect. This is how we set up it up with Lakekeeper, but it's not absolutely required to do it that way. The most important learning here is that we should store permissions basically at a central place, and typically the physical storage is not a good place to do it, and also the engine is not good simply because it's not shared. So permissions in the end should be stored close to the catalog, but can also be stored in a separate system right beside it, which is what I'm assuming now for the rest of the talk. So I have a little production checklist that we fill during like the talk, and well, with a few things basically that we learned. So the first point is that permissions should be managed centrally so that they can be shared across engines and the catalog. And all components in our platform should be connected to the IDP because otherwise we can't share permissions. And well, I mean, there are many reasons why we want to, connect different things to our identity provider, but I can't I've seen it done wrong so many times that I really want to highlight this here. So any system that we have in our data platform that creates personal access token, passwords, client credentials, all of these things, any system that does that is an IDP. It creates credentials. And that's a very bad thing to do. So we should really make sure to not have this in our platform, apart, of course, from our actual IDP. Okay, so now we talked a little bit about where we should store permissions. Let's next talk about how we can enforce them. Because it's nice that you know that a permission is there, you also have to ensure that it is applied to the data that we want to query. So how can we enforce permissions today? So the first option that we currently have is, as part of the Iceberg REST catalog specification, we have vended credentials. So a little recap how that works. So we have a query engine, and the query engine contacts or has a user token, right? So some kind of authorization header. It accesses a catalog. The catalog hands out temporary credentials that are scoped to the location of the table. It hands them back to the query engine, and then the query engine can go ahead and access the storage of this specific table. We also have remote signing as an alternative. The important bit there is it's only working on file level, which currently means typically table level security. We can't get much more fine-grained than table level security as of now. So with the catalog enforced security that we have today, we get table level security, but it works for literally any client. So even if this client is running, on a local Jupyter or something, we don't rely on this client to filter out data before returning it to the user. So it works for all different clients out there, and it's standardized as part of the Iceberg REST specification. So next up, compute enforced permissions, which is, the next option that we can use. How would that work? So we have two different users now, and those users, again, share a query engine. In this case, we can imagine this being Trino. There aren't actually that many query engines out there that are powerful enough to connect to an external permission system, but Trino, luckily, is one of them, so I'm using Trino as an example here. So we have two different users, and they log into Trino using two-factor authentication. What I'm showing here now is also something that I have a demo later on, and the code is available. So the user logs into Trino, and Trino in this case can have a system user, something that Trino uses for all its queries to the REST catalog. The REST catalog actually receives the token, checks it, validates if it validates the token with the IDP, and also validates the token with a permission system. With Lakekeeper, we are using OpenFGA, a CNCF project, to store all the permissions in, so it's externally, but it could be really any permission system that we decide to connect to. Not having a standard here, as I said before, is, I think, something that we might want to change in the future. So what would happen next? Well, now Trino would go ahead and actually check the permissions. Trino itself can't talk OpenFGA, but we have really good tools such as Open Policy Agent, for example, available today that can translate permissions between different systems. And this is also something that we're going to see later. So we have a little OpenFGA agent in between there, which Trino uses using its Open Policy Agent plugin, and which translates the permission from our catalog to the query engine. So Trino is then checking the permissions for the user and filtering the data, right? In here, retrieving the data and filtering the data before giving it back. And this filtering step, of course, is crucial, right? If Trino wouldn't filter the data, the user would get any kind of data possible. So This requires a trusted compute engine that is managed in a controlled environment by administrators which users can use. Okay, so this is the first way basically how query engines can do this. So they query an external permission system and apply those filters locally. There is a second version, and this also allows for column and row level security because querying is done or filtering is done in the engine, so they can apply these kinds of filters there. We're missing a common understanding for row level filters as of now, but maybe user-defined function is a way forward. Columns are a bit easier. The next option that we would have, or another type basically of how query engines can enforce permissions, is via impersonation. And I'm using Starox as an example here. They just implemented this on their main branch, and I'm really happy to see it. The way this works is that a user logs into the query engine as usual, but this time the query engine actually uses the token of the user, exchanges it with the IDP for a token for the catalog, right? So we should never, of course, reuse tokens. If we issue a token, it has an audience, and in the audience is the application which it is intended for. So when I log in to Trino, or Starox in this case, I would have a token with audience Starox, or the ID of the application, and then Starox would exchange it for a token for the catalog. So now we have the permission route here. So Starox impersonates the user, makes a query to the catalog, and well, we validate the token. Again, we validate access, and then we return metadata and also the storage credentials, and retrieve the data. So, So two different ways basically how query engines can enforce security. The first one can work with more fine-grained access controls. The second way is currently depending on, well, catalog enforced security under the hood, right? So it's based or limited to table level security. So putting them side by side, like as I already said, like they have very different focus, right? So with catalog enforced security currently, it's table level security, but it works for every client out there that speaks Iceberg REST. So also like a Pi Iceberg on a user's local machine, which is great. And then we have query engine enforced security, which allows like more fine-grained access control, but it requires isolated user sessions and a trusted compute engine. So a little bit harder to set up. In the end, we need both. Like we can't live with one of them as of now until we find like a good solution to secure everything with the left-hand side here. Yeah, so there are two more ways that, well, that we can discuss on how we want to, on how we can enforce permissions. So one is enforcing permissions on the storage level, as I said before. But this, to do it right, with all like aligning with the goal that we laid out in the beginning, we would require an Iceberg-aware storage system. So a simple object store wouldn't do it. We would need something like S3 tables, which currently outside of AWS is not really available. And the last one is encryption, and yeah, I mean, Ryan also mentioned it a little bit this morning in the keynote. Like, this is a very tricky thing to do, so I'm also not going to talk longer about that. Maybe just one motivation for that. Like, if you hand out, it's of course super expensive to re-encrypt data somewhere, right? So if you ever hand out a key to a client, you have to assume that like this data is going to be accessible for indefinitely. So it's a really hard thing to do right, and probably not the right way to go forward with column level security. So we can add like two more things to our production checklist here. One is, so for untrusted clients, we should currently use vended credentials. We should never hard code S3 or storage credentials anywhere, and we get table level security for that. And then for trusted clients, we should somehow ensure that permissions are shared with the catalog. For example, as we'll see later on in my demo, via with Trino, with something like the Open Policy Agent connector. Okay, so now we've talked a little bit about permissions, and now I want to like talk very briefly about identity. Called the section Who Am I? So we can only share permissions between the catalog, between query engines, if we have, you know, the same understanding of identity. If we look at the REST specification today, like it doesn't put, there isn't that much in there regarding authentication, and that's a good thing. So we have a little section at the very top which specifies the different security measures, like this catalog thing, by the way, should be gone eventually, but it's still there today. But basically this says that, well, you could authenticate to the catalog using OAuth or bearer authentication. And until, like, I think last year, we also had an endpoint in there, the v1 OAuth tokens endpoint, which actually required a REST catalog to be an IDP. So this required a REST catalog to hand out tokens, which of course is the exact opposite of what we want. So luckily this is deprecated for security reasons, so we shouldn't use it anymore. So the only thing really that the REST specification tells us is, well, we can use in bearer authentication or OAuth 2. If we now look at the client applications, well, we have basically four different four different security protocols implemented. So first is we have token authentication. You just specify a bearer token, it gets handed off to the server. We have some OAuth 2 flows. Unfortunately, none are currently suitable for users, but I think that will come. Some folks are working on that. For people, like they are all machine focused. And then we have very specifically for AWS, we have AWS SIG-v4 for workloads on AWS. So basically, like the message here is, like, we should use OAuth. It's a very mature standard, of course, for identity management. So maybe 2 slides on OAuth. What is OAuth? It's a delegation protocol that lets people allow applications to access things on their behalf. And if we translate that into our data world, it means it's a delegation protocol that lets people allow query engines to access data on their behalf. Pretty much what we want from it, right? So it's a delegation protocol that allows us to grant a machine on our behalf access to some kind of data. Yeah, and also maybe extending this, so OAuth 1 actually was only suitable to authenticate people, humans, and that was luckily extended in OAuth 2 now with flows like the client credential flow that is also suitable for service accounts. And then maybe like one other word you often hear in this context is OIDC, which is also based on OAuth, so any OIDC server is also capable of most OAuth flows and just adds an additional ID token on top of OAuth. So yeah, the next slide is just an overview of like the most important flows that we have in OAuth 2. So the left side is meant for humans, and there are a few more flows for humans, but not that many flows. It's very important that if you log in as a user, you should always use an interactive flow, because without an interactive flow, you cannot use things like two-factor authentication and things like that. So there are 2 main flows currently in the OAuth specification. One is the authorization code flow, like which all of you, like if you log into some kind of service and then you get redirected to your IDP in your browser, you log in, this is the authorization code flow. And the second flow that you can use for that is the device code flow, which you use typically like when you log into Netflix on your TV, you scan a code, you get a device code, you enter that on your second screen on your mobile phone, for example, and that is the device code flow. Both of these are suitable for people, for humans. And then we have a few, like 2 other flows, like the client credential flow, which is the non-interactive flow that we're all using with Iceberg today. That is not suitable for humans. It's a machine-to-machine protocol, right? Because it's essentially, this is username and password, right? You have a client ID and a client secret, and as we have all learned already 20 years ago, people are not suitable to keep passwords safe. So we don't want passwords, we need something else. Yeah. So currently we have this in most Iceberg clients. Some clients like PyIceberg are extendable enough so that we can just add the others. And now that we have the auth manager merged in the Java implementation, we'll also be able to add more flows there. Yeah, and then there's the token exchange flow, which is which could be better defined in the RFC, let's put it that way, which is also non-interactive and which pretty much does everything else. So we can use it to refresh tokens, to exchange the tokens, like I said before, from one application to another. It's pretty versatile, and I think that's also part of its problem. Okay, so I guess the last point here on my list now is we should use interactive flows to authenticate people. Yeah. Okay, so now I have talked a little bit, and now I want to basically to show you what I've had on the slide before in a little demo. Okay, I think I should put that in here and show that it works. So I'll show a little setup now with a central permission management system, which is in my case OpenFGA. I'm using Laykeeper as a catalog, and we're using two different query engines basically to connect to it. We have a shared Trino, which uses the Open Policy Agent bridge that we ship as part of Laykeeper to translate permissions for Trino. And then we have, Apache Iceberg basically, which uses the same, or which can authenticate the same humans basically with the same permissions. So now I think I need to change to show my entire screen. There we go. So it's demo time. Okay, so I'll first show a little bit the configuration down here mainly of Trino, because I think this is the most important one. So with Trino, we have Trino connected here to an IDP. The IDP is just Keycloak running in my Docker container, but we could use like literally anything else as well. So the whole code is available in the repository. I have a link also later. It's just a Docker Compose up that you need to run to get it running. Yeah. So we have Trino connected to the IDP. As I said before, sharing permissions only works when we also share identities. And then we have a little access control configuration here for Trino, where we basically say that it should, we have a policy URI, which is Open Policy Agent, OPA, that's running in the same Docker setup, basically. And a batch URI so that we can more efficiently do batch requests for permissions. That's basically the setup of Trino. So now let's have a look how this works. Like this will seem very trivial right now, but it's really hard to achieve today. It's something that you would expect to work, right? To share permissions. So, I have the catalog running now, and I have two different users for the catalog. So one user is, we can just maybe log into it. One user is called Peter, and the password is not secret, it's Iceberg. And we can log into it, and then, currently we have one warehouse, one Iceberg warehouse. It's on a local min.io that we run as part of the Docker Compose, and it's currently empty. No tables, no views. So now, Trino is also completely empty currently, and now I'm creating a new catalog inside Trino here with this little script. So it's of type REST. We give it a client ID and a client secret. This is the technical user of Trino. This is not the human, of course, logging into it. So let's run this. So, and also maybe we're using vendor credentials here, so you won't see any kind of S3 credentials here. And here, because Trino is connected to OAuth 2, we now get a little URL here, so we need to authenticate with the IDP. I was already logged into Keycloak, so that's it. So now I've created a new connection in Trino. Now going ahead, maybe opening the next notebook here, and we are also going to run it as the user Peter, and we're just going to create a few tables here, so a finance revenue table and a finance products table. So let's run that. And we should log in somewhere again here, because this is a new session. So now we've just created a few more tables, and we can also see them here. So we have now a finance namespace, and we have two different tables in here. So now I have a second user, and this second user is called Anna. And this second user is now, first of all, trying to query query these tables. And so I'm just running the notebook here. It's in a different user, in a different browser. So here I'm logging into a different user. Also, Iceberg is the password. Iceberg. Here we go. Authentication succeeded. And we see like we're not allowed to do this. Why is that? Because we just created new tables. Anna doesn't have any access rights on that. So now we can open Lakekeeper. We see also here we don't have any kind of project assignment currently, so we can't do anything. So let's go back to Peter. Anna wants to query which table? The products table. So now let's open the products table, permissions, and we grant a few permissions here to Anna. Select, for example, save. So we now stored the permissions in an external system in OpenFGA. Well, and now we granted the permission with Peter, and now going back here to Anna, we can see that the select now works. So as expected, I mean, we have the permission and it works. And even like one step further, we can use the same user now, logs into PyIceberg as a human, using a human flow, device code flow it's in this case. And here we go. So we sign in, yes, and here we go. Now we can query the table with the data in it. So we have two different query engines, and both of those, with both of those, we enforce the same set of permissions. As I said, it sounds super trivial, but it's actually like not that easy to achieve, especially with shared query engines. Okay, so so now we have seen like that it works, but we have also seen that like the way that we do this is already like, it is quite complex, right? It's not super trivial to set something like this up. So while we do have a very good standard here for identities, namely OAuth 2, we are still missing like a common understanding on how we convey permissions between different services. So what can we do about that in the future? So there are a few things currently that really help, I think, in bringing us forward here. So the first is Auth Manager API. I think I mentioned that earlier as well. The Auth Manager API, new API in Java, allows us to plug in new authentication handlers so that we can add new authorization mechanisms into Java. Yeah, I'm going to work on a Rust integration as well, and I think PyIceberg is also on the agenda. Then we merged, well, last year already, the server-side planning endpoint. So now as part of the REST specification, we have an asynchronous endpoint where clients can ask a REST server to do the planning for it, right? And because this is an asynchronous endpoint, we are able to do a little bit of stuff there. Because it's asynchronous, we don't need to return immediately, but we have a little bit of time. So especially regarding maybe column or row level security, there is the option that the catalog writes out files also for untrusted clients, removing some columns, removing some rows. But it's super costly, and we really need to think about if we really want this. So there is this option out there that we can do currently. We haven't implemented it yet. Looking at Polaris there, I don't think it's there either. I'm not sure if it's planned. It's a hard thing to do, but it might help, right? And then we have user-defined functions, which are, well, I posted the proposal number in there, which is currently being discussed. User-defined functions, so column-level security is actually quite easy. Like every query engine has a good understanding of what a column is, right? But targeting specific rows that users shouldn't see is a much harder problem, because you need a common understanding of the filter, right? So the UDF proposal that we currently have might help there. And then something that, well, I said before, so more query engines are now starting to implement token exchange for user impersonation. So Starox, for example, as I said, is just working on that, or just finished working on that. It's not yet released though, so I'm really happy to see this coming up as well. And in the meantime, and I think I could show this a little bit with the demo today, like we're not completely helpless, right? So we have good tools out there that help us translate permissions between different systems. And tools like Open Policy Agent can help us very well to close the gap until we find like a common standard. There have already been like some proposals. I think last year there was one from Jack regarding a common permission system. It was probably a little bit too specific. I really hope that we can follow up on this with a common standard, maybe even larger than Iceberg. Yeah, so I think that's it from my side. Here's a link to the code if you're interested. So yeah, I mean, the statement holds. We want one identity provider, we want one source of truth for permissions, and then we want different query engines, and some of them are shared between users. And this is what this demo shows. And yeah, with that, I think I'm done, and we still have a few minutes for questions. Thank you. Yeah.
Thank you for the talk. So I have a few questions. One of them is around the choice of OpenFGA, I guess specifically for the Lakekeeper setup. And then also with the service accounts, what are your thoughts on like the Spire, Spiffy, SVID, I guess, ecosystem and having that be used for the identity exchange swapping? Okay, so
yeah, so why did we choose OpenFGA? So I mean, with Lakekeeper, this like the authorization backend is swappable, and we have other folks implementing like their own or connecting to their own proprietary solutions. So like it's not set in stone, right? We can exchange this if we want to. We opted for OpenFGA as a first implementation because it's super powerful, it scales really well, and it also integrates with other business applications, right? So our permission model might not be limited to just Iceberg, right? We might want to grant permissions on Iceberg tables based on other entities that we have in our company. And as a modular system such as OpenFGA is very well suited to bridge these gaps. So you can have multiple OpenFGA models, and then you can connect them like with a little bit of glue as part of OpenFGA, and this way you can propagate permissions from between different applications in business entities. OpenFGA is also really powerful in like having a good hierarchy. Yeah, so these are some of the reasons, I guess, why we chose it. And regarding Spire, like I think this is a very interesting approach. Like we haven't implemented it yet, but it's definitely on the roadmap to also interface with that. Simply because it gives a little bit more freedom, basically, to the different applications in our data ecosystem. Yeah, so definitely interesting. More questions? One over there.
Eric Anderson from Bloomberg. It's great to see you demoed OPA because we're actually the developers of all that technology. I think the one thing that you missed is we also open sourced an S3 proxy that reads the exact same OPA policies in Trino as in the S3 proxy, so you can enforce stuff at the S3 level. So they share policies between them, and you can bring, we've already brought Snowflake and other engines directly to the same Iceberg stores with the proxy in there. So that was the only thing your demo was missing, by the way.
Yeah, thanks. Yeah, I'll make sure to add that to the demo in the future. I think like S3 proxy is something that we see popping up like over and over again now, right? It's also something that like you need to do it right on the infrastructure level because you need to be very close to the S3 nodes to actually implement it. But yeah.
It's under TrinoDB /
yeah. Yeah, I've seen the project. Yeah, thanks. Okay, where do you?
So do you use OpenFGA for storing row-level security policies as well?
So we haven't implemented row-level security yet, and I'm hoping that with that we can build up on row-level security when the UDFs are merged, basically. So when we have a common understanding of what is a row between different or a row filter between different query engines. We are working on column-level security currently. I think it will come in roughly 2 months or so, and that is also stored as part of OpenFGA. So basically, you have different confidentiality groups, right? And then you can grant people permissions to these groups, and you can assign them to columns. And the actual evaluation is done with OpenFGA, yes. Yeah. The result of that is though that if you have an, like you said, a client either to trusted or untrusted, and if you have an untrusted client and the client is not allowed to actually see a column, then like until we have one of the other solutions in place that might come eventually, we're not going, like we might reject that request, of course, because we don't want to leak data. Yeah. Yeah, 2 more, I think.
Thanks. My question is about like, so this implements table level security, right? And as you said that like you would prefer a universe where you don't have trusted compute. So why wouldn't, I mean, like I want to understand why didn't you go towards the storage layer for basically controlling access to the table itself, and then you don't need trusted compute? So basically when credentials based on that?
Yeah, so I mean, so on the, even if you control it on the storage level, column and row level access controls are very, very hard to do, right? Because a Parquet file, well, yeah, is a columnar file, but there's, of course, all the data in there first, right? So it's really hard to do with that. And we already have the same level of granularity. Like if we accept that we just do it on a file level, also with an S3 proxy, then we have exactly the same granularity that we already have with vendor credentials today, right? So yeah, I guess this is the main reason there. So, I mean, we can, with vendor credentials, we can use untrusted computes today, just with table level access controls. Yeah.
Is the single identity provider a mandatory, or is it possible to have multiple identity providers? Let's say you have 2 companies working together. Let's say one company controls the compute, the other company controls the IRC, and another company controls the S3 buckets. Things like that. How do you envision these kind of scenario work?
Yeah, so like from like with vendor credentials and everything along those lines, and also with like filtering out on engine level, luckily we don't need S3 to be part of the same identity system, right? Because it's enough if the catalog actually has those credentials. But then, of course, the question is, what do we do if we have, you know, different companies with different engines? And so we can connect that on IDP level, I guess. So we have, OAuth 2 is really great at federation. So if like one company has a user, that user can get an identity in a second company's IDP, and we can use that to gain access to the data. With Lakekeeper itself, we can also register like arbitrary many IDPs, like we can connect 5, 6, 7, 8 different IDPs if we really need to. We currently, by default, ship with 2. So one is an OIDC IDP, and the second one is a Kubernetes IDP, so that we can natively authenticate, for example, a Kubernetes operator provisioning things for users, right? So that could also be another option, but it's typically better to federate on the IDP level because IDPs are really good at that. Yeah. Yeah.
One thing to add that you just asked is we're about ready to open source a Trino connector, and in that we're doing token exchanges, but the discussion is to move that out of the connector and start offering that at the catalog interface level, so you can start doing STS exchanges to start addressing the actual problem that you said. So that's, I don't know, 6 to 12 months out, but I think that's going to go into Trino, and you're going to get it at the catalog level.
Yeah, I think that is actually also the right way forward. The current token exchange in Trino works only with a handful of IDPs out there, and well, also I guess the problem is because the RFC isn't specific enough, and because we implemented it a little bit, well, uncommon, let's put it that way, in Iceberg itself. So yeah. Okay. I think, let me just watch the time. Yeah, one more, but then we have to finish.
It's going to be quick. So I have a question about the UDF. So I understand you're trying to specify the format of the UDF itself to be Iceberg native. But then, specifically for row level filter, what would that UDF look like? What would it return? Is that also going to be like? Is there some standardization there, you think?
So okay, we have to see where this proposal goes. Like the idea is that this is like these simple primitives are similar between engines, yes, so that we do have a common understanding. Because like I think what like many people offer as the ideal solution, which is an intermediate layer for like something like Substrate, is a far way off, right? So we can't go down that road currently. So it's more like SQL snippets that are understood by multiple engines that represent filters. Yeah. Okay, then I think we're done. Thank you very much.